Welcome to the Rapid Plus TCT Theater. We have some exciting things happening today at the event. I hope you've enjoyed all the presentations so far. My name is Debbie Holton. I'm the Vice President of Events for SME, and just so glad that you're here with us today. We've got an exciting announcement. I have some friends with me here. I have Dr. Michael Greaves from Florida Tech, and I also have Anil Sachdev with General Motors. And we're going to talk a little bit about a new initiative, an industry-wide initiative that SME is leading to answer those million-dollar questions you guys want to know the answers to, which is, can I print it? And should I print it? And if I'm printing it, what's the best machine and material and process for that? So we've got 2 short videos, and then our presenters will be coming up, so thanks.
What's the best machine, material, and process for my part? Answering these questions quickly and accurately will help you make better decisions, be more profitable, and maximize design for additive manufacturing. SME is proud to launch a new initiative, the User-Driven Independent Technical Evaluation of Additive Manufacturing, or ITEAM. ITEAM is a virtual repository of additive manufacturing machines and materials, plus the tools you'll need to evaluate additively manufactured parts. SME is creating ITEAM working in collaboration with Dr. Michael Greaves, renowned expert at Florida Tech, General Motors, U.S. Car, and other industry leaders in automotive, aerospace, and beyond. Together, ITEAM is developing a new expert system that will greatly accelerate profitable additive manufacturing. Join us. Be a part of an exciting new community where you'll have the tools you need to evaluate your parts, maximize design for additive manufacturing, plus match up with the best machines and materials. The time to accelerate profitable and effective additive manufacturing is now.
I'm Dr. Susan Smith, Chief Science for Manufacturing at General Motors, and I run Manufacturing Systems R&D at GM. I cannot be with you personally today at Rapid, but I want you all to know I'm extremely excited about the announcement that SME is making today about the Independent Technical Evaluation of Additive Manufacturing, or ITEAM. We at General Motors believe that additive manufacturing is a significant technology that can really change the face of manufacturing in the 21st century. But specifically for automotive applications, we're going to require new processes and some really significant development in additive manufacturing materials and systems, allowing us to mature from merely using it as prototypes to having production-ready manufacturing systems. We're very excited today about the announcement that SME is making of ITEAM and its additive manufacturing machine and material repository platform. This is a major investment in this effort. And I will leave it to Dr. Michael Greaves of Florida Tech, and later to my colleagues, Dr. Anil Sachdev, Dr. Pat Spicer of General Motors, to give you a preview of this exciting initiative. And I look forward to meeting and working with many of you in the near future of this effort. Thank you.
Good afternoon. Oh, that's weak. Good afternoon. There we go. So I had to get up early to do this. You know, you guys can be a little more enthusiastic about it. So what I'm going to talk about today is this ITEAM launch, and how we're going to do this is I'm going to talk about sort of the overall perspective of this. I'm going to turn it over to my colleague Anil, who's going to talk about the GM's contribution to this, which is their methodology for evaluating the can I and should I, and then Professor Sen from Florida Tech is going to basically give you a brief overview of a proof of concept that we're developing that shows you that this is really possible. This is my facility in Florida. I get a lot of visitors during the winter. It's in Palm Bay, Florida, which has been very supportive in terms of looking at a high-tech corridor. What a lot of you may not know, that this is part of the Space Coast, and we're doing a tremendous amount in aerospace. NASA Kennedy Space Center is located nearby. Northrop Grumman has their new large facility where they're building an unnamed aircraft that everybody should guess what it is. And so we're basically created the Center for Advanced Manufacturing and Innovative Design, which is a combination of industry and academic approach to research and development. And so ITEAM is part of what we're looking to do. And so what ITEAM's mission is the creation and operation of a dynamic repository of all additive manufacturing equipment and capabilities to evaluate this idea of can we and should we for current and newly designed manufactured parts. Now, while I think that the opportunity for current parts is getting better every time we have one of these events, I think the real disruptive opportunity is going to be in new parts, or what we call DFAM, Design for Additive Manufacturing, which I'll talk about in a second. We think that sort of the wisdom of the crowds is a big opportunity in terms of disruptive and new technologies. And so what we wanted to do is to create an ecosystem and a community of users' experiences to basically feedback as to how additive manufacturing equipment works, especially since there's rapid development in this area. You know, the ability of users to basically be able to feedback their experiences, we think is critical for the advancement of this. We want to influence and guide the design for additive manufacturing, DFAM. And so this is the idea of that we're going to basically create parts that we could not create in the past because of subtractive manufacturing. So we want to basically look at parts that are a lot lighter weight, but have the same structural characteristics, the ability to basically take assemblies and consolidate parts into a few parts from many parts. I think it is the big opportunity in terms of additive manufacturing. By the way, I don't think people quite understand what this is going to mean in terms of major manufacturers taking back some of things that they farmed out to the supply chain. So I think it's going to have huge supply chain implications, and you're going to see OEMs basically get back into the manufacturing area if they can basically design these parts where there's a large reduction in assembly. GE has done that in their engine components, and so I expect that we're going to see that. Now, there's a lot of issues in terms of what are the criteria. I heard today, you know, we need to train our engineers on design for additive manufacturing. The problem is we really don't know what all that means at the moment. So there's a fair amount of work that we really need to do in order to look at good design rules for additive manufacturing, and we're very active in doing that at the Florida Institute of Technology. And then what we're looking at is the fact that SME is a trusted third party, and to basically be able to separate some of the claims of equipment from actual results. And again, that'll not only be SME, but also from the user community's feedback. So we really want to do those sorts of things. And so ITEAM is independent technical evaluation of additive manufacturing. And the team part is what we think is really important in emphasizing here as we move into this initiative. What's our strategic direction? So our strategic direction is based on, there'll be a test after this, they tell you that? No. This is General Motors' SAM CT framework. So it stands for size, accuracy, material, and then cost and throughput. And so this idea of, you know, can we build it, which is the technical piece, but the should we build it is what drives business decisions. So as an ex-CEO, you know, there are a lot of things you can do, but you don't do because it isn't economically feasible. Now, you know, in the computer industry, you don't like the amount of computing power you have, wait 18 months and it doubles and take another crack at it. Additive manufacturing probably isn't moving that fast, but clearly the trend for advancement is fairly huge. I want to direct your attention to what looks like a small part down in the lower left corner. But this is, we think, the guts of how we're going to basically be able to evaluate manufacturing equipment and material, is the ability of being able to have this repository so that not only do you design the parts, but you can figure out which machines to build them on. This differs from subtractive manufacturing because that's fairly established, and cutting metal and plastics has been around for a long time. The machines and how they're set are going to make a big determination as to whether or not something can be done, and that evaluation we think is extremely important. So what we're creating is a platform, and so this whole idea of, we're in a platform environment. If you think about it, Uber doesn't own any cars, Airbnb doesn't own any hotel rooms. We don't want to own anything from an SME ITEAM standpoint. What we want to do is provide a platform so that we can connect users and suppliers in providing capabilities for the community. And we think if we can do that, we will advance dramatically, or at least accelerate this adoption of additive manufacturing. By the way, that's a pretty good book if you haven't seen it. But it's about how we're really focused on platforms today, and that's really sort of the key to economic success. So the platform architecture looks something like this. I come out of the computer industry, so I've had a lot of experience. In fact, if anybody ever bought a lottery ticket online, I did the first one. Did our research at Jackson Prison, by the way, because it was a numbers game. That didn't excite the governor at the time, but it turned out to be okay because the technology took that over. But at the lower level, we want to do user validation, billing and administration. So security is certainly on our minds in terms of being able to do that. So think of us as sort of the Apple store in terms of being able to not only do our own things, but basically create opportunities for suppliers to develop capabilities. Our key opportunity is going to be the Rapid Virtual Repository, which is basically going to be this repository of the machine and materials that are out there, and that will be sort of a constantly updated and scrubbed repository, so that we'll be able to basically give users the latest information. Everybody's here, for 1 week talking to people about machine capabilities. What do you do the other 51 weeks of the year? And so this is our answer. Think of it as a virtual trade show, but with a lot more intelligence in terms of being able to help you make decisions on the basis of what you need to do. And then I have a security level, because I think the key here is to make sure that we have secure facilities, and especially protecting intellectual property. Our model is going to be that we will not take any designs into the system. It'll be done behind the user firewalls, but the issue is going to be that we want to make sure that first of all, if we don't have the designs, they can't be corrupted from us. But second of all, is we're very concerned about being able to protect any list of users or machines or things like that. And then finally, the top level is basically kind of the slots where the applications will fit in. So we're going to show you the General Motors developed SAM-CT tool, which is a proof of concept. This is not the only tool that you're ever going to see, and nor in fact are we going to make the claim, do we want to make the claim that this is the tool that everyone should use. What our intent here is to show that this is really possible to do the kinds of analysis and selection that we need to do off of geometric designs. Another key piece of it is we are going to provide a community forum. So users sharing with other users their experience on particular machine material things. So as Dr. Smith from General Motors talks about the TripAdvisor for additive manufacturing, we think is going to be a key aspect of being able to advance it. So the problem right now is when users go off and buy this machine, they're on their own, and they basically sort of take their chances about that. It may be another user can tell you that with a different setting or a different material, you're going to get better capabilities. And so we think the community aspect is going to be an important piece, and we think that we will, as part of Rapid in the future, sort of highlight the major contributors who participate in this. And then we'll have applications that software providers, people that have expertise and want to develop as free apps user-provided apps and even for fee apps. And so this is the overall platform that we're developing, and we think that it will sort of meet the needs that we're setting out here for our ITEAM capabilities. So the Rapid Virtual Repository platform consists of three aspects. It consists of the machines, materials, and then machine material systems. And so what our focus on will be is to create and keep updated this repository so that in essence it will be a virtual trade show 365 days a year with all these additional tools. And so what we're hoping and we're planning to do is to be able to add expert systems that will be able to do this. Now, you've probably heard, well, gee, you know, the CAD people are going to create this capability within their CAD systems. And the answer is, yes, they will do some of this, but they really don't have the capability nor the access to be able to keep this kind of repository up to date. So we're talking to all the CAD suppliers about connecting in to our system, because we think that really is the key to have this very trusted independent third party SME be able to provide this capability. So we will also have add-ons such as images, brochures, demonstration videos that will be populated by vendors so that they can get the word out. Again, we're looking at sort of two pieces of the puzzle here. This is a pro vendor opportunity, because they don't have the ability necessarily to reach everybody who they want to reach. But we want to make sure that when they do reach out, it's with trusted material that we can basically say you can rely on what this is. And so we also have a connection for service bureaus so that you may not have the right machine to produce the particular part that you want at this particular point in time. So we expect that the service bureau companies will participate in this, because they might have equipment for one-off kind of things, or even proof of concepts to prove out that you can produce these parts on these particular machines. The AM advisor, the additive manufacturing advisor, is basically this idea that says users will feedback information on the machines. We will curate this, because I can see that company A, who's competing against company B, puts in bad remarks about company B in a competitive situation. So we're going to curate this and make sure that we have good information in the system. But we think, again, that having users basically be able to feedback information will be beneficial. So we really are sort of counting on this idea of building a community, an ecosystem of the folks that we're going to need to basically move this ahead. I think that if we all sort of work together, we can basically make better advancements than if we have this sort of fragmented information you can't rely on. Having been on the board of directors of some big public companies, I can tell you that, first of all, middle managers and even senior managers aren't going to bring big purchases unless they have a lot of confidence in that purchase is going to produce the results that they desire. And secondly is you basically have to have the confidence in the information that you're getting that says I can rely on it and basically be able to spend that kind of money. So the ecosystem for us looks like this. Is obviously we want this to be end user driven. I mean, we think that the end users, banding together, can basically gain a lot of capability and advantages in being part of a group that pushes us forward. Obviously, the machine manufacturers are key to this, and sort of derivatively, so are the AM service bureaus. But we also have manufacturing organizations. Obviously, SME is one of them, but National Center for Manufacturing Sciences is also part of this. We expect on the government side to bring in folks like NIST to talk about not standards. I mean, I'm a believer that when you have an industry that moves this fast, standards slow it down. So what I call harmonization. Basically, everybody plays nicely in the same sandbox. The academic institutions have a role to play because, again, we're basically plowing new ground here in terms of not only the additive manufacturing itself, but how do we design for additive manufacturing? And in fact, how do we move information around the supply chain, what I call the supply network, in order to be able to have all this stuff come together at the same thing. And then finally, but not last, is the software providers, the CAD providers. So the big four are Siemens, PTC, Dassault, and Autodesk. You know, they are all talking about designing for additive manufacturing. How that basically takes place, I think, it ought to be driven by the user community as opposed to their individual perspectives on this. And also, as I said, they won't be able to maintain a repository, so that's something that we're going to do. But again, you know, I want to emphasize that we're driving this from the end user community. So in terms of design for additive manufacturing, I mean, if any of you have taken a close look at it, we need to develop new design discipline rules. We need to have some sort of ability to look at assemblies and see if we can pull them together in clusters that we can produce from an additive manufacturing. So we need to develop new analysis and methodologies. Materials knowledge is key. I mean, you know, we're basically sort of creating new materials for this that we haven't had in the past, and these materials need to operate on these particular machines. So clearly a lot of this is being done by the machine manufacturers, but the material science piece is huge in what we're doing. And then finally, we have to create machine material accuracy combinations. And so there's a lot of work to be done. It's not enough to simply sort of create new machines. We basically have to create kind of a new discipline designed for additive manufacturing. And I think there's an important opportunity to get ahead of the curve here in being able to do that. For two reasons. One is it's just necessary in terms of developing that, but secondly is we really have this methodology ready so we can train the new engineers coming out of school to be able to do that, but also retrain some of the older engineers who are not going to be sort of familiar with this. So we think that there's some really nice opportunities here in terms of doing that. Our rollout is scheduled for early next year. We are in the development cycle. We're certainly looking for feedback on capabilities and things that are sort of even not only must have, but nice to have. So this is an example of the design for additive manufacturing. As I said, I think that eventually this is going to be done at the design level and the CAD level. And then we basically are looking for a CAD DFAM design. And there's a sort of an example of a chassis that was done traditionally, and then one that has the same structural characteristics done in additive manufacturing. Although probably today, the one done in additive manufacturing will cost you about 100 times the current one. But eventually, I think that cost will come down. So with that, I'd like to turn it over to my colleague Anil to talk about General Motors, who have been one of the huge drivers in terms of getting this together and their methodology. And again, if General Motors believes that this is eventually going to be production level, I think that all the other industries that are not producing millions of units should think hard about, can we and should we with respect to additive manufacturing. Neil?
Thanks, Mike. Before I start, I'd like to say my director, Susan Smith, does send her regrets that she cannot be here, and I'll try to do my best to represent her. So continuing with the ITEAM approach and looking at this vast technology opportunity, how do we come together and move fast so we can bring this technology into production? Now, production is the key word and not prototypes. So we're going to talk about the thought process of bringing this technology into high volume production, and that's what I'm going to describe to you, which is the basis of creating this ITEAM approach. So I assume I hit this. Mike showed you this framework. Now I'm going to peel this framework apart because we need to be very simple about the approach that we're going to take. And this approach is shown in two sets of figures that are combined together. One of them is the technology showstoppers. The overriding question is, I've come to this big show. Why can't I do it today? What are my hurdles that are preventing me from taking this technology into high volume manufacturing? That's really the question. And so we have two components of this, which we consider are three components, which are the technology showstoppers. And I'm going to explain each one to you, put it in the automotive perspective: size, accuracy, and material. And then we have what we call the economics of it, which are the economic irritants, which is the cost and the throughput. So next, what I'm going to do is take each of these apart and walk you through each of the elements as we look at it in the automotive world. So when we look at size, yes, we do make very small parts, but we also make some very large parts. And just to put it in perspective, it's very impressive to go into one of our stamping plants and see the whole side of a big van stamped in one piece. That is the bandwidth of what we deal with automotive. Clearly, we're not there today, but that is the big opportunity that this technology has to address. Maybe not all of it, but whatever it can. So I'm not worried about it because we tend to supersize everything. So I'm sure one day we will reach the sizes of many of the parts that we do make. Net shape accuracy is a very important piece, especially when you look inside the engine components, for example. Most of our components are made to parts per million tolerances, and the tolerances are actually on the order of 10% of the powder size that you use. So we will need some sort of post-processing on this for sure, but hopefully one day that also will disappear and give us components that are completely to net shape. Materials, if you look at the periodic table, automotive deals with every possible material in the periodic table if you include hydrogen that is used in the fuel cell. So we do cover everything all the way from low-cost materials like iron and steel to platinum in the catalytic converter. So we do deal with a vast array of materials, and generally when we look at materials, it is surprising, but the bulk of the vehicle is still steel. It's about 1,000 kilograms of the vehicle is still steel on an average vehicle that had its roots right here in Pittsburgh. Now, when you look at that and you convert that to some sort of a cost, you take just the cost of a vehicle that you'll purchase in a dealer divided by the mass, it comes to about $20 a kilogram is the vehicle that you purchase. So that's the kind of numbers we have to bring this technology to on an average. Now, of course, there's a lot of underlying benefits of additive that allow you to make adjustments to that. So that's kind of the cost piece. And throughput, the 60 million vehicles are produced per year. When I joined GM almost 40 years ago, my first assignment was to work on spark plugs. At that time, General Motors made 2 million spark plugs per day. That was the volume that product used, and it had one spark plug has about 6 independent materials inside it. So clearly a lot of complexity in the volumes, and that translates to throughput, where we talk in milliseconds and seconds per component. Clearly not there today, and don't know when we'll reach there, but additive does bring a totally different approach of compressing the entire supply chain. So different rules of engagement will be there when we try to bring all of these elements into the final decision making of, can we make it? Many times, yes, we can, in units of ones and tens and hundreds. But when we move to units of millions, it's a different ballgame that this has to address. So when I sit here today, looking at this vast show, I have to make a decision of how I am going to take my part that's on the left, which is thousands of parts and tools, and the numbers of suppliers over there. How do I create the match between the two? The best I can do today is huddle in a conference room with 5 or 6 colleagues and try to remember what everyone has said, or maybe look in our laptop or Google it or something and make some sort of a decision on what I think this is the best way. And I get 3 good answers, and I say 5 answers that are not correct. So that's my options that exist today with just us and the knowledge that we have. But I know for a fact, by the time I go out of this building and to the airport, the technology would have changed, and by the time I land, there would be another announcement by some entrepreneur or innovator telling a better way of doing something, and I will have to bring that into my mindset to allow me to make the decision. So it's not going to work because the information is generated in a high volume, and it is also at breathtaking pace. So clearly I need some sort of a math-based tool, which is what was the nucleus of creating this ITEAM, is this math-based tool that allows me to make an objective decision based on some very robust information that is not biased to just me or my colleagues or a small group of people. And so that's what we want to do today, because I'm not able to make the decisions due to lack of information. So we need this bill of materials or math advisor, which Mike talked about. And this was really the thought process that led to developing that framework, where we are going to take this, create the expert system that will now tell me, wait a minute, I have 2 more answers than I had before. Those 2 more answers is a business opportunity and revenue stream for everybody that's involved in this. 2 more suppliers who can provide their capability to making what I want to make, and I have 2 additional suppliers that I can reach out to, or 2 technologies, or 2 ways of thinking, or 2 of everything else. So that's really what this expert system is all about. And it also, because I'm from research, I also want to know, beyond my wisdom and my thinking, is there a way, something that I have missed? Or the supplier community also has an opportunity to see if they have missed something, or do they have an opportunity where venture folks can invest to create all of that. And that all flows right out of this expert system, on top of whatever you will get from the ITEAM approach. So clearly, a lot of business opportunities for everyone who participates in this, in the entire ITEAM approach. What I showed you just now was the thought process, that kind of grassroots in a way that led to this tool that we want to develop. And now, well, we'll turn it over next, a little bit more of where we get this information from. It will be from suppliers, users. We are here today. A lot of conversations going on. A lot of inputs will come from various places in the media, people writing letters, people talking to each other. We have no shortage of information exchange in today's world. So we are actually information rich, and maybe analysis, takes a little bit more time. So I'm going to turn this over to my colleague, Professor Sen. But just to summarize what I've said about the ITEAM, it's a repository of high quality information, because it's done by an independent body that has more than 200,000 members who each want to make sure that there is high quality in the information that is obtained, and high quality in the information that is displayed. Coming from research, we want to influence innovation and invention, because there is still a big gap between where we are today and where we want to be. influence standards or homogenize things, harmonize things, because each one has their own approach. Clearly, we need to get to that part of it. And while the information is a repository, there will be applications that will come that will question this repository based on your requirements. So I'm going to put in that I need to make this at this volume, at this cost, with this material. It will now probe into this database or into this robust information and give me the options.
So this is what we think is possible with respect to the ITEAM thing. And as I said, this is only sort of one initiative to sort of prove off the concept. So with that, we have maybe time for one question before we're at the end. So if anybody has a question, be happy to entertain that. Otherwise, myself and my colleagues will be around to outside the theater to answer any questions. Any questions? Yes, sir.
Could you talk about how the model of collaboration looks like, or do we contact you guys and?
Yeah, so there is on our website. Good question. Planted in the audience. We have a website called sme.org/ITEAM, and there is a button you can click to basically indicate your interest, and we will get back to you after that. So we would like participation. We also will start sending out kind of periodic updates as to where we're at, and certainly the SME staff will be available to help with that discussion. So again, thank you for the question. Thank you very much, and enjoy the rest of the show.